All right, now we are in week 8. Now let's go through these theory questions first. Now the question 1, now as I mentioned before, now these questions are based on week 7 lecture. Basically we covered the views. So let's go through these questions first. Now question number 1 is asking how many, now let me actually open a Word document to record all my answers. Word. Let me first open a document, Word document. So right, so I take the bank. Let's make it a little bigger. Maybe 16. This is week 8 tutorials. Okay, so question 1. Let's go through the question 1. Right, so how many columns will be in the result set when the following statement is executed? Now this one is, now what they have given is a kind of a straightforward select statement. So what they're asking is how many columns, right? Not the how many rows, but how many columns, right? So this is a very straightforward select statement. So they are selecting the movie title. I think M stand for movies, yes, and movie years, surname, first name. Now remember, what do you mean by this? Now in this case, now they are selecting actually 2 columns here, surname and the first name from the actor table. I think A stand for the actor table. Now they are joining actor here, you can see. But in this case, we combine these 2 columns using these special characters, right? So if you wanted to combine 2 columns in order to produce the report, you can do like this, right? So the first surname comes and then the space and the last name, also the first name. And then they are putting a kind of a heading for the last column, right? So this is very straightforward. So how many columns when you execute this? What is the number of columns in our final reports? So title, movie year, so 2 columns, and the third column is a combination of these 2 columns, right? Surname and the first name. So we have basically 1, 2, and 3, right? 3 columns. So this is straightforward select statement. So selecting 3 columns from the movie, and they are joining the casting table, and they have joining again the actor table. So there are 3 tables joined together in order to produce this report. So the answer is very straightforward, 3 columns. So what are these 3 columns? Title column and movie year column, and the final column is, what is the final column name? Actor name. Okay, final column name is actor name. Okay, actor name. So pretty much straightforward. So 3 columns, title, movie year, actor name. Right, so question number 2. Right now, we are now coming to the views. Right now, this is a complicated statement, and we are coming to the views. So, what is a view? How are you going to define a view? Right. So, what do you mean by the view? View is a variable, right? So, it's the name of the variable, or in other words, view is a SQL statement that's stored inside the variable which accesses the data in a table. So that is how we going to define the view, right? So now remember, views, when you create the views, it act like a table, it behaves like a table, and we can use the name of the variable or the view name inside the select statement, right? Or even we can actually join some tables based on the contents of the view, right? So remember, I have explained that in the last lecture. Okay, so the answer is, now let's write the answer. They ask us to define the view. So we can say view is nothing more than an SQL statement that accesses data in a table or tables, right? So the table actually contains the data, not the view. Yeah, the table contains data, whereas a view contains what? View contains SQL statement, isn't it? SQL statements that refer to table data. You can actually define something like this, right? But when you select the view inside the select statement, it will execute that particular select the statements which we recorded inside that particular variable, isn't it? Okay, so that is what the view means. Okay, so that is the answer. So we can actually give a statement like answer like this, pretty straightforward, very simple answer. Right, so that is question 2. Question 3 is question 3 is what occurs when the following statement is executed. Now what they have done here, they have created a view. Right now, this is how they're creating a view. So create a view. So this is a this is the state. This is the what do you call keywords, and this is the name they have given as. This is again keyword, and then what they have done actually, they put this select statement which they have introduced inside the view. So what will occur when you run this statement? How to answer it? It's actually nothing much, but what it has actually doing here is the database management system will create an object called mview, right? So mview is we can say it's a view object, right? So it contains the SQL statement as indicated in this question. So that's about it. That is about that's about the answer, right? Okay, so what we can say is the database, or we can say a database object named mview is created. So mview is a view object. Okay, it's not a table object, it's a view object. Visit object. So this object contains what? The SQL statements as indicated in the question. That's what actually has happening when you execute that particular, when you create that view. Okay. Okay. So is it clear? I think this is very clear, right? So remember that views will not going to record any data. We will not going to record any data. Okay. What it record is a bunch of SQL statement. That's it. Question 4. How many columns will be in the result when the following statement is executed? Right now, what they are doing is, rather than running this SQL statement, now they are running mview, right? So they are selecting the columns from the mview. So select asterisk from mview. How many columns it will going to result? So again, the answer is how many columns? Very easy. 3 columns, isn't it? Title column, movie year column, and the actor name column, right? So answer is that, right? So because we are executing the same SQL statement, which is stored inside this mview object or mview variable. Okay, so we can say question 4. Actually, can copy the same answer as we written in here. 3 columns. Okay. So is it clear up to here, guys? Question up to question 4. Is it clear? I want you to show off your hands and tell me whether it is clear for you. I think it's very straightforward. There's no complication. We're just creating an object called mview. Mview contains a bunch of SQL statements, and then we use that object to run some reports. Yeah, right. That's what we are doing here. Right, so that is answer to question number 4. Now we are going to move to the question number 5. Right, now what has happening here? Now we are using the same view object, right? So there is selecting the same view object, but now we put a kind of a restriction to which rows we are going to want. Now what it does is, what will occur when this statement is executed, right? Can you write your answers? I want you to write the answer. What will happen if this statement is executed? So take 2-3 minutes. So what will happen? Right, so Aiden is correct. So however, the others also writing the same answer like what Aiden says. Yes. So what happen is it will eliminate the rows from the result set that do not match the condition move year is equal to 1998, right? So earlier when you run this statement, select asterisk from MView, that means it will extract all these rows which satisfy the select statement, isn't it? Right? So it joins three tables together and producing these results. And so it will actually produce the whole every single row probably in our movie table and the actor table and the casting table. Okay. But what is we are doing here is filtering out, right? So we have we put the condition, we eliminate the rows, but we want the rows which satisfy movie is equal to 1990. So that is what it's doing. So very straightforward. Now let's write the answer. The question 5, I can say it will eliminate the rows from the result set that do not match the condition. The condition is movie year is equal to 1998. That right? Okay. So we can say the remaining rows in the result set are the answers. Or the answer to this question. Okay. Right, so that is about question 5. It's straightforward. Right, now let's go to question 6. Why we need views? So list 3 reasons why views are useful. So I want your answers, right? So I want you to refer to my lecture slides and give me the reasons. Okay, so what are the 3 reasons why we actually have views, why we have a views, why we create views? Remember, I have told you that. So refer to my lecture slides. I want everyone: Oscar, Raj, Shia, Thomas, Yunus, Joseph, June, Aiden, Ang, Kai. I want everyone to refer to the lecture slide and find these 3 reasons, because these are the questions will appear in your test too. Okay, this is very important. Right, I want you to refer to my lecture and then everybody need to provide the answers. So I'll give you 3-4 minutes. Okay. Yeah, Joseph, you are correct. What else? I need the others to answer as well. Yeah, you are correct. So one of the main, now let's see the question 6. So one of the main reasons why we need a view is why? View can be used as a security mechanism, isn't it? So views can be used as a security mechanism. Now remember, I have told you, I have explained you last week. If you have the table with many columns, we don't want that give the access to each and every employee to access all these columns, isn't it? So we can actually group these employees into different levels, and we can create different views based on their level of the access, right? So the management, we can give one view. HR people, we can give another view. Basically, the other employees can give you another view, right? So that is one of the main reasons why we have the view. So that is one of the, actually that's one that be the um, major I think importance of the views. Okay. The other thing is views can hide the complexities of the codes, right? Uh, Complexities of the SQL statements. Now remember, I told you last week, if users wants to produce some reports, so analyze some data from different tables, what we can do is, rather than giving them the access to the whole tables, we can provide some we can create some views which inner joins many tables as the users want, but specific columns only. And then what the users do is they just execute that piece of view, and then they extract data to the report generators like Excel or Tableau, whatever, and then they will use these data to produce different reports by themselves. Yeah, to analyze the data. So that is another important one of the advantages, right? Why we create the view. The other important advantage is probably we can actually now sometimes I think I haven't actually mm, uh, explained this, but sometimes we can actually simplify uh, existing we can say existing uh, legacy codes. For example, sometimes if the table schemas we need to change time to time, right? Table schemas can need to change time to time because of the requirements of the business. So what we can do is we can create views for the existing systems based on some columns, right? Some columns actually not going to change, but sometimes the table can have we can add some different new columns to the tables, but unchanged columns can be remain in the view. So we can actually these columns who used by these power users like management team actually doesn't feel there's a undergoing changes in the coding, because the view always use the columns that we have assigned to it. That is another advantage by having the views, right? So these are basically three main advantages why we create views. Okay. Yeah, so I think most of the answers are correct which you have given. Right, so that is the answer to question number 6. Question number 7 is very straightforward. Does a view stores any data? So your answer is no. No, it doesn't. Yes, that's right. 7. No, it doesn't. Right. Right, so that is the question 7 answer. Question 8. So what statement is used to delete the view name MV? So if I wanted to get rid a particular view, how to delete the view? It's like deleting a table. It's same like deleting a table, isn't it? Because the view is a virtual table, right? Because it's a virtual table. It's not a physical table, but it's a virtual table. So we can delete the view same as we delete a table. How to delete table? What is the command? Drop table command, right? So in this case, we say drop mview. That is the name of the view. Oh, sorry, drop view mview. Drop view mview. So this is a keyword. Okay. So this is a keyword. So this is how we delete a particular table or particular view. Right. So that is the answer to question. Is it 8? Yeah, question 8. Right. So question 9. Can you insert rows by using the view name? Using a view name instead of a table. Can we insert the rows for the tables using a view? Yes, we can actually. We can, right? So remember, I have told you now in this case, in this view, for example, this view have selected the title columns, movie year columns, surname columns, and the first name columns, right? So we can now insert the data one of the for all these columns as it, because it selected these columns from the table. So yes, so the answer is yes. Question 9. Yes, you can insert data using view. Right, so that is a good thing about the views, right? Question 10. Can you delete the rows by using the view? Can you delete the rows using the views? Now, once you insert the data using a view, you can also delete the data using the view, right? But you now how to delete the data from the view? So the answer is actually yes, you can delete. But now remember, it's very dangerous. It is a bit dangerous. Now, why it is dangerous using view? Why? You need to be very careful when you're deleting the data from using the view. The reason is, remember I told you last week, because some tables can contain constraints which is not reflected in the view, right? So view can be select certain columns, but not the whole column from certain tables, right? Because some tables can contain constraints which actually apply to certain columns only. If these columns are not present inside our view, then we will get an error message, right? So we will not successfully deleting the data. Okay, so that is why that deleting the data is a bit dangerous. Okay, so how to delete the data from the view? So I can use delete command, delete from, then now in this case this is MV. Okay, delete. Okay, so this is a keyword as well. Okay, so are you clear with that? Are you clear with that? Now, if you want to prevent people to delete data from the view, what you can do? If you don't want the people to delete data from the view using a view, what you can do is you can put that read only clause, isn't it? Right? So when you, if you want to, now let me write, if you want to prevent users deleting data, what you can do is you can add read only clause, isn't it? Read only clause. So how can you do that? How can you add read only clause? Remember I have told you. So first we create a view, right? So we give a name, and then we record a bunch of select statements or bunch of, right? So we just write the select statement, and then what we can do is at the final row we'll write select, say for example select from some table name, and then we finally write with read only, right? So if you put this statement, then you can prevent people deleting any data using the view, right? Right, so I think I have explained that in last week lecture. Okay, now you need to remember these stuff, right? How to create a view, why we creating the view, how to drop the views, how to delete the data from the views, how to insert the data to the data using a view, how can you prevent people to deleting the data, this is how you preventing it. So these kind of things are examinable in your final test. Okay, right, so that is about the answer to question 10. Any do you have any queries or anything related to these 10 questions, anything? Otherwise we can move into the next question. Anyone? Do you have anything? Aiden, Anne, Joseph, June, Kai, Oscar, Rajiv, Raj, Thomas, Yunus, Ali Khan, do you guys have anything? No? Right, then if you don't have any queries, then we can move to the next question. Okay, so question 11, 12, and the other rest of these questions actually focus on ERD designs. So let's come to these ERDs. Okay, so we slowly read these case studies, and then we construct the entity relationship diagram. Okay. So let's go through question number 11. So you have been asked to model the housing information for the local government. Each house which has a unique address. Okay, so they're talking about house unique address is owned by one or more owners. Each owner owns a percentage of the house. Example, the person A has 30% ownership while person B has 70% of ownership. Okay. Each house has a number of bedrooms. Each house has a number of bathrooms. Each owner may own more than one house. Okay. Each owner is identified by the name and also has the phone number. Each house may be rented by one or more renters. A renter is identified by the name and also has a mobile phone numbers. Some houses are not rented at all. So what they ask us to do, they draw the entity relationship diagram based on the above narrative and convert the entity relationship diagram to the relational schema. Show some example data stored in all the tables generated by your entity relationship diagram. Okay. So actually we can, if you draw the ARD diagram, so the rest is piece of cake. It's very easy. The main challenge is drawing the entity relationship diagram. Now, how to start? Now, remember, I have given you, I think, around 9 steps. The first thing is when you have this kind of problem, what I will do is now highlight the important things. Okay. If you highlight the important things or the objects, you know, these are the things we need to capture. All right, so they are talking about this is the housing info. Now this is the model we wanted to build for the local government, so our council. So the local government, do we need any any object or any entity to represent the local government? Do we need it? Is it an object or is it an entity in our database? Can anybody answer this one? The answer is no. So we don't need any entity to represent the local government. But the reason is we have only one instance of that, right? So one instance of that. So we don't need it. And they are talking about houses, right? So do we need entity for the houses? Yes, we need it. Now, what kind of entity is that? Is it a strong entity or is it a weak entity? That is what we need to now rectify that. So house in this case is a strong entity. Why it is a strong entity? Because each house has a unique address. Okay, right. So now we know there is a entity called the house. So what we can do is we can actually go straight away and then we can actually capture that information. So this is my entity name is house, right? So we capture that information. So the unique address, so address is looks like the primary key, isn't it? So this is the primary key, the address, then I can go there and then say, okay, I have the attribute address. So I say home address, so H. So that's basically the primary key. So I underline. And these houses are owned by one or more owners. Okay, so they are talking about owners, right? So do we need an entity for the owners? Because if you read the second the next sentence, each owner owns a percentage of house. Yes. So that means we need to actually record the information about the owners because they owns the house, isn't it? So the owner is basically what kind of entity? Is it a strong entity or is it a weak entity? Because it says owners have so now in the last sentence in the first paragraph it says each owner is identified by the name, right, and also has the phone number. So these basically two attributes which is allocate which we can allocate it to the owner. Yeah, so looks like a pretty much strong entity because each owner has a probably unique name or maybe they may have the unique phone number, right? So let's capture the owner. So let me put the owner here. This is the owner. Right, so looks like owner is pretty much a strong entity, isn't it? So it has a mobile phone number, it has a name. So I just put owner mobile and it has also the owner name. So I'll take the owner mobile phone number as the primary key, right? So owners own the houses. That is what it says. So there is a link between owner and the house. Yeah, ownership link, right? So owners own houses. So what now? Is there any limit the owners can own houses? No. So one owner can own many houses, and one house can be owned by many owners. Right? One house can be owned by many owners, isn't it? That is what it says. Each owner owns a percentage of the house. Okay, so that means we can't keep the many-to-many relationship. So that means we need to build a weak entity in the middle, isn't it? So if we have the weak entity, definitely we need to now have that relationship. So we need to reverse the many ends towards the weak entity side. So what actually we are going to record in this weak entity? What is we are going to recognize? This is where we record who owns which houses, isn't it? So this is actually house owner, right? This is actually record who is on the which houses, right? So what would be the primary key for the house owner, weak entity? So we need, in order to identify the each unique owner for each house, we need to take the primary key of the owner and the primary key of the house, right? So that means if I put the relationship names in these two lines, right? I need to underline these relationship in order to show that we are taking the primary keys to the weak entity side, right? So how many, so what else? Now we have two attributes already: mobile number, owner's mobile number, and or house address. Yeah. So in combine, it make a composite identifier. So what else we need to actually record in this particular uh, entity? Yes, Joseph says ownership percentage. Yes, so we need to actually record the percentage own because this is what, right? So they say person A 30%, it says person B 70% for a particular house. So we need to actually record how much of percentage each owner owns, right? So let me go back to here. So that means there is a one extra attribute comes there. we can say percentage of ownership. Percentage of ownership. So how many attributes there now we have in the house owner entity? 3 attributes, right? Owner's mobile phone number, which comes from the left side. Owner's the house address comes from the right side, and then it has its own attribute, percentage of ownership. So altogether 3 attributes. Okay. Right now we need to recognize cardinality and participation relationships. So if I go to from left to right, so one owner can actually own many houses or many ownerships in different houses, so one to many. And then same applies to the right hand side. If I travel from right to left, one house can have multiple owners or many owners, so one to many. So that is the cardinality relationship. And then if I put the cardinality constraints, one house or one owner may own may own 0 or many houses, right? So we can have owners without having any ownership sometimes, right? They may have sold the houses, right? So we don't have mandatory here, isn't it? So it can be optional many, right? Optional many. But if you go from right to left, if you have some ownership, that ownership must allocated to one owner, because we can't have the ownership information without having any owner, isn't it? So the constraint in that left hand side is mandatory. Okay. Same applies to here. Now, but in this case, if you have the house, house can have you must have at least have one owner, right? We can't have houses without having owners, right? So house must have one or many owners, right? But if you have one ownership, that ownership must allocate it to one owner. Okay, so that is how the cardinality constraint comes into that side. Okay, right. Okay, right now. So we have actually rectified the problem in this paragraph. Now we jump to the second paragraph, right? So each house may be rented by one or more renter. Okay, now it comes to the renters, right? So there are renters. So renters are renting the houses. That is what it says, right? Renters are renting the houses. So each house may be rented by one or more renters. A renter is identified by the name and also has the mobile phone number. So, right, so they're talking about the renters. So do we need to capture that information? Yes, it looks like another entity. So what kind of entity is that? Is it a strong entity or a weak entity? So they have actually identified 2 attributes here: name of the renter and the mobile phone of the renter, right? So looks like basically another strong entity. Yeah. So we can actually create that strong entity somewhere here. Okay, so I will create it here. Sorry, I can remove this one. Okay, I'll create a entity like this. Right, so strong entity. So now we have again 2 attributes: mobile phone and the name of the renter. Now you can see the owners entity and the renter entity actually looks same. Yeah. So this is the renter. So what are the attributes? So we have the mobile phone. So this is the renter's mobile, R mobile. I just put R mobile. And then we have the renter's name. So R name. So the primary key is definitely renter's mobile. So renters, what it says is renters are renting the houses, right? So is there any limitation that one renter can limit in a house? No, right? So one renter can rent many houses, and one house can be rented by many renters as well. That is what it says here, isn't it? Each house may be rented by one or more renters, right? So each house can have many renters. So it looks like again a many-to-many relationship between the house and the renter. So if you have many-to-many relationship, we need to create a weak entity. Yeah. So let's create that weak entity. Okay. So if you have the weak entities, then we need to actually reverse the relationship. The many need to be attached to the weak entity, right? Right now, what we are going to actually record in the this week entity. This week entity actually records which houses are rented by which renters in a given period of time, right? Right. So this actually records, let's say, house renter, something like this, right? So what is the identifier for the house renter now? So how to identify the renter, a specific row in the house renter, we need to know who is the renter. So we need to grab the identifier from the renter. So underline, we need to grab the identifier from the house address, then the underline. So let me put the relationship names first. Let me put renters has renting houses uh, rented by the renters, right? Right. So yeah, so we have only two attributes appearing here, right? So only the renter's mobile phone and the house address. Okay. Right, so we identified this relationship. Now we need to find out the cardinality relationship. Right, now let's go through the cardinalities now. So one renter can rent either zero houses or many houses, right? So zero or many, right? Oh, that means optional or many, right? Uh, so there is no mandatory saying the renter must rent houses, right? There is no mandatory requirement like this. So this is optional. So other way around, if you have one house rental details, it must actually associated with that particular renter. So we have the extra one here. Okay. The same applies here, but now this is the cardinality relationship one to many. The cardinality constraint, if you have the one house, that house may be rented by, right? May be rented by the renters. We can have houses without having the renters, right? Maybe the house is at the moment is repairing or upgrading, etc., etc. So we may have the renters, right? But if you have the house renter, that house renter must belongs to the one house. Okay. Okay. So that is how we put the cardinality constraints. Right. So we identified now all the major entities. So there are basically three main entities or three strong entities and two weak entities. And we identified the attributes and we identified all the primary keys. Right now, I think do we have more information here? No, only these are the information. Right, so they say some houses are not rented at all, right? Some houses not rented at all means, now that is why we put this constraint optional. The houses may have renters, right? But if you have the renters, it must belong to one house, okay? So that is why we put the participation constraint optional in this case, okay? Right, so we have now constructed our entity relationship diagram. So what they are asking us to do is convert this ERD to the relational schema. Now I think you can do it by yourself. Now the first we need to convert all the strong entities, right? And then we can convert all the weak entities. Now if I ask a question, which actually entities record the most important information? Uh, it's actually the most important information actually recorded in these weak entities. Remember, when the entities are becoming more weak and weaker, we record more important information, right? Um, so these two weak entities actually record the most important information. Okay. So house renter details very important because this is important for these local government to make sure that the renters are maybe paying the rent or whatever the reason. So who is the renter to keep the tab on, right? And the ownership of the house is important for the local government in this case because they may want to impose some kind of collect some, what do you call this, revenues from the houses, right? So they can actually determine how the revenues can be distributed. So basically, these two it can do this uh, records most important information. Okay. So now you can actually convert the relational schema very easy. I'm not going to do that. You can do it. And also then we can convert, we can write the create table statement based on this. Okay. So that is the answer to the question number 11. Okay. So now we have another question. Now this question looks a little longer. And then after that, I have actually given kind of a step by step again, reminding you the steps that you can adapt to do the entity relationship diagram. So I'm not going to do that now. Let's go through this question number 12. Okay. So read this question. Take the time, read this question and see what entities we need. Right now, let's go through this question. So let's read it. So Eat More Food is a company that makes the food recipes available to customers via online service. Each recipe requires a number of ingredients. Each recipe is written by one or more authors. Now, if you read these couple of sentences, it looks like there are so many entities, isn't it? They're talking about Eat More Food, the company. So do we actually require this company to represent in a entity? No, right? So we don't need that. So looks like we are actually developing ERD diagram or database for this particular company. So we don't need an entity to represent this company. Yeah. So they're talking about food recipes available to the customers. So they're talking about the customers, food recipes. So probably these two maybe the entities in our database, right? So each recipe requires a number of ingredients, right? So recipes have ingredients. Now looks like another entity or attribute. I don't know. Maybe we need to read it. And it's each recipe is written by one or more authors, right? Looks like another entity, right? So authors are written the recipes. Now let's actually uh, highlight some of the keywords. So recipes, I will highlight the recipes. Looks like an uh, important maybe it may be entity. Now let's anyway we highlight it, and then they are talking about the customers. Again, probably we need to capture the customer details, so I just highlight it. And each recipe requires a number of ingredients, so I will highlight that as well. And then the recipes are written by the authors, right? So I will highlight that as well. So looks like 1, 2, 3, 4. This looks like four entities, isn't it? But we don't have any idea. But let let's keep reading, right? Then the next sentence or next paragraph, while some recipes may have same title as another recipe, each recipe submitted has a unique idea. Now when you read that, definitely the recipe looks like a strong entity, right? Because recipes contains the unique IDs, right? Each recipe has a unique IDs. Looks like a strong entity. Actually, we can capture that information in our uh, here the diagram straight away. So what I will do is I'll make a kind of let's see, somewhere here I will draw that entity. I will name this as the recipe, 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 and let me capture the attribute straight away, so I can remember. So recipe has a unique ID, so it looks like a recipe ID, yeah, something like this. So I just put RID, right? So I will underline that. Okay. Uh, Unique ID. The authors may submit any number of recipes. Now they are talking about authors. Looks like authors are submitting the recipes, right? Looks like kind of another entity, isn't it? It looks like authors and recipes are interacting together, yeah. So let's come back and identify another entity, probably the authors. So let me somewhere here, put it here. Authors are, so let identify the author. Looks like a pretty much an entity. So it's what it says is authors are submitting the recipes, right? That is how it looks like. So it looks like authors can submit many recipes, and one recipe can submitted by maybe one author or many authors. We don't know at this moment, right? So let's keep reading. Yes, authors may submit many number of recipes, so many recipes. Now they're talking about each ingredient used in a recipe will be stored within a database. Okay, now they're talking about the ingredients, right? This looks like another entity, isn't it? Because if you think about, now let's capture that straight away. Each recipe looks like having many ingredients, right? Uh, Let me capture that here, somewhere here. in case we need it. So let me write it as ingredients, ingredient. Right, so I just record that information for the time being. Go back. So where is my yeah, so looks like if I actually go back to my diagram, looks like ingredients. So one recipe can have many ingredients, right? One too many, and one ingredient can be used by many recipes. So it looks like there is a relationship, right? So let's keep it as is for the time being. Then let's read it. Each ingredient used in a recipe will be stored within the database. Yes, we have open entity to represent the ingredient. Each ingredient will be available from one or more online suppliers. Now they're talking about suppliers. Okay. Okay, looks like another entity, right? So let me capture that as well first. So ingredients are supplied by the suppliers. So let me capture somewhere. Okay, so somewhere here, suppliers, right? So ingredients supplied by the supplier. So one ingredient can't supplied by many suppliers. One supplier can. So it looks like there is a relationship. Yeah. So let's go back. So details about each supply will also be stored. Yes, we capture the supply details now. Right, now let's go to the next paragraph. To use the system, a customer must, right, now they're talking about the customer, right? The customer we already have there. The customer must be first uh, register their names and the email addresses with Eat More Food. Okay, now we have some clue about the customers. So customers need to be registered first in order to use the recipes. So the name and the email addresses looks like the attributes of the customer, right? So that means we can straight away capture that information. So do we have the customers here? No. So let's capture the customer information. Probably I will somewhere here. I will write it there. So customers. So let me customer. Okay, so they have actually indicated two attributes. Two attributes for the customers, right? Isn't it? Customer name and the customer email address, right? So looks like customer email address is the primary key because it's unique. So that means each customer is having the unique primary key like email address, right? Because no two customers will share the same email, isn't it? So email address probably the appropriate primary key in this case. So customer email and customer name. So customer email looks like the primary key. I will underline that. So it looks like customers can use many recipes. Yeah, something like this, right? So the relationship looks like that. That is how it sounds like to me. Okay. Right, a unique customer number is assigned to right now, but they're thinking about unique customer number. So that means we need to slightly modify. Now let me highlight this. A unique customer number looks like now. Okay, So that means I need to record that information. So that means email is not the primary key. So we have the unique customer number instead of, so I just write somewhere here. So they have customer, I just put C number, customer number. Okay. So customer number, right? So we have 3 attributes for the customers now. So whenever a customer downloads a recipe, the system must show the date that recipe was downloaded. The date that the recipe was downloaded, right? That is important. So we need to record the downloaded date for each customer, for that particular customer. If the recipe is downloaded more than once, so that means the system must allow a customer to download more than one the same recipe, right? The system must record the date of each individual download, right? Now we have a clue. So that means where is the date actually going to record? So date actually going now recipes. Now if you think about this relationship, one customer can download many recipes, right? One recipe can be downloaded by many customers. So the date actually belongs somewhere here, right? So date goes somewhere here. So that means if we have the many-to-many relationship between there, and then we can't keep the many-to-many relationship anyway, we create a kind of a weak entity in the middle. That weak entity actually attach this date attribute, right? So that is the idea. So what we can do is we can straight away actually delete this line, and then we can create that weak entity in the middle straight away. So that is obvious. So that is easy. So let me create that weak entity. Okay. So when you create the weak entity, many and always attached to the weak entity side. So actually what we are going to record here, download the information simply. So download the info. So that is the information we recorded in this this weak entity. So then we record the date download. Okay, the date. So download date. Right. So my question is now, what is the primary key for the download info weak entity? So obviously we need to know who has downloaded. So we need to know the customer number. So I need to grab that information from this side to that side. And also obviously I need to know which recipes that download involved with. So I need to actually grab a recipe identifier from this side from the recipe to the download info entity. And then is that enough to identify the unique download information? No. So that means I need to actually highlight download date as well. So we have now 3 attributes. All 3 attributes in this case is work here as a composite primary key, right? Customer number, recipe ID, and the download date, right? Right, now let me put some relationship names here. Let me make it as, yeah. So customers as a download info, and one recipe can be downloaded by many customers. So we need to underline the relationship names. And now let's see the cardinality relationships. Okay, so one customer can download many recipes, right? One customer can download actually 0 many recipes, so optional. And one download information must belongs to one customer, right? Then the other way, so this is one to many, right? That is the cardinality relationship. So if I put the cardinality constraints, one recipe may have again uh, optional 0 to many, right? So it can be, we have customers cannot be, they don't download it at all, right? Because that recipe is a very bad recipe, so nobody want to download, so it's optional, right? But if that particular recipe involved in the downloading, that recipe, that information must link with one particular recipe, right? So mandatory that other side, right? So we have completed this. Now let's go back to, yeah, so I think this paragraph we already done. Now let's go through the rest. So below are some examples of information that is currently stored in East Morfood in handwritten documents. Right, now let's go through these. So these are the list of recipes, and then each recipe has the recipe number and the recipe name. So these are the two attributes, isn't it? Recipe number and recipe names. So that means we need to now, we can identify that in our entity relationship diagram. So we have recipe number already identified, then now we need to put the recipe names. So this is the second attribute, recipe name, right? So we identified that. Right, so we identified these two attributes. Now let's go to the recipe example. So one recipe, this is the recipe number and recipe name, right? So this is the recipe name number, yep, for that recipe. Now you can see this recipe is written by two authors, isn't it? Fred Smith and John Davies, and each has a mobile phone numbers, right? So that means there is a connection between authors and recipes here. Looks like one author can have many recipes and one recipe can be written by many authors. So looks like a many-to-many relationship in this case. So if you have many-to-many relationship, that means I need to now create a weak entity here. Okay, so let me create that weak entity first. So here we are recording which authors written which recipes, isn't it? So for the time being, I just put author recipe, author, sorry, author, okay, something like this. So we need to link now. So once you create the weak entity, many side attached there. Once you create the weak entity, again the many side attached to that side. So one to many, that is how the cardinal relationship works. So if I go back, so what are the other attributes that we can capture here? Author names and the author phone numbers. So in the author, we have the names and the phone numbers. I can say here the author name and author phone number. Do we have any author IDs or anything here? They didn't mention any author IDs here. So that means we need to rely on probably author phone number as the primary key, right? Uh, so we have identified that. Let us now think about the cardinality constraints or participation constraints in this case. So one author can participate many times, so it's optional actually. He or she can write anything, or they can just stay without writing anything in a particular month. So optional, but if there is a recipe associated with the author, that recipe must associated with the author, right? So mandatory. And the other side, uh, and then if I think about this relationship, one recipe, if there is a recipe, one author must be there. So one to many. But if there is a author information, it must belongs to one recipe. Yeah, right. So the mandatory relationship from left to right. So what is the identifier for the author recipe? If you take the author's phone number and the recipe ID from this side to this side, actually that is enough to make a author recipe as a perfect identifier, right? Uh, so a combination of the recipe ID and author phone. So it's make a unique ID for in this case. So that means we need to now highlight the relationship names in order to indicate we are taking the primary key from this left and right to the weak entity. So let me write some relationship names. So let me put authors has the recipes and recipes written by authors, right? Right, so looks like this we completed this as well. Now we can move to the next section. Let's go through the example. So we captured here. Right now we are coming to the ingredients of this particular recipe. You can see there are a lot of ingredients involved, and each ingredient has, now see, the ingredient has ingredient IDs and the ingredient names. Now we have captured that information here, ingredient entities, so these are the attributes, isn't it? These are the attributes of the ingredient. So that means we can now record that in our ERD. So ingredient ID details and ingredient names, isn't it? So what is the primary key for the ingredient? Looks like the ingredient ID is the primary key, right? So let me write that first. So this I would put ingredient ID and ingredient name, right? So ingredient ID is the primary key. So looks like, now if you go through here, you can see one recipe can contain many ingredients which has many quantities, and probably this ingredient can be shared by many recipes as well, right? So bread, baked beans, etc., etc. Can be shared by many recipes. So if I come back to this relationship. It looks like many to many, isn't it? One recipe can contain many ingredients, and one ingredient can be shared by many recipes. So many to many again. So that means we have a weak entity in the middle. So let's delete this line and create that weak entity. Let's create that weak entity first. Okay, we create that. Let me now, what is that? So let's give a name. So let's say this is my recipe ingredient. Recipe ingredient entity. So recipe ingredient entity. I just put ing. Okay. So that means now we can link this. So always, as I mentioned, if there's a weak entity, many end attached to the weak entity side, and one end attached to the main entity side. So one to many. One recipe can appears many times in this table, and also one ingredient can appears many times in this table. That is what we mean by one to many, right? Then I can actually, now what is the primary key for the recipe ingredient? So we need to know which ingredient used by which recipe. So that means I need to take the recipe ID from this side to right side, as well as ingredient IDs from right side to left side. Okay, so looks like these two attributes comes there. And then what else I need to record in recipe ingredient? Now if you go through this, you can see the quantity details. So each recipe ingredient has quantities, right? So for example, white bread, we need to use 2 slices. Baked beans, I need to use 750 grams, 1 tin of 750 grams, etc., etc. So that quantity details we need to record somewhere here, isn't it? So this is my recipe quantity, or quantity of the ingredients. Right. So now I can actually, now let me write the relationship name. So one recipes has, I just put has, and one ingredient, just put something like that. Okay. Right, so we identified the cardinality relationships, and then here's, so let's put the cardinality constraints. So one recipe, if there is a one recipe, it must have one or many ingredients, isn't it? But if there is a one ingredient in a one recipe, recipe ingredient, if there is a one ingredient, it must belongs to one recipe, right? And the same as here. But in this case, if there's a one ingredient, that ingredient may or may not belongs to recipe ingredients. But if there is a recipe ingredient, it must belongs to one ingredient, right? This is what you mean by this. Okay, so I think we have completed this. Now let's go to the rest. So we have recorded the quantity, right? Right now we have the instruction details. Right now this recipe has some instruction details. Do we need to record that? Yes. So where are we going to record the instruction details in this our diagram? Yes, so it belongs to the recipe, isn't it? So instruction details goes there. Recipe instructions. So we recorded that one. Okay. Now what is this? Download details. So recipes are downloaded by different customers. So they are email addresses, dates, the names, did we capture that information? Customer, emails, yes. The date download, yes. And the name of the customer, yes. So all these information we already captured, so we don't need to worry. So we did that, and now we are coming to this side. Okay, so now here, as you can see, okay, now what is this one? Now this is a copy of the ingredient suppliers. Now there is a one ingredient called white bread X100. So these are the possible suppliers of these ingredients, right? So now they are given some attributes for the suppliers. So supply codes and the supplier names. Now let's capture that. Okay, so we have the supplier here. So we'll capture the supplier details first. So supplier codes and the supplier names. Okay, let me write that information there. Supplier code and the supplier name. So looks like a strong entity, isn't it? Suppliers, because supply code is unique. Right, so suppliers are supplying the ingredients, and one ingredient can be supplied by many suppliers. That is what it says, right? So these ingredients are applied by 3 suppliers. So looks like there is a many-to-many relationship. So that means if I have the many-to-many relationship, same principle applies. I need to get rid of this and then attach a weak entity. Okay, let me attach a weak entity. Right, attach the weak entity. So we link these entities, we link here, and then as a rule, as I mentioned before, many end attached to the weak entity side, but one end attached to the other side. Right, so what is this actually we are going to record? We are going to record which ingredient supplied by which supplier, right? So how we going to determine each unique row in this particular case, or in other words, what is the primary key of this case? We need to take the ingredient ID, so that means I need to underline this part, this relationship, and also I need to grab the supplier code, so that means I need to underline that relationship, right? So let's give a first the name for this particular entity. I will name it as ingredient supplier, ingredient supplier, right? So that is the name of the entity. So let me put the relationship now, supplied by a supplier belongs to, right? So do we have any other attributes to ingredient supply? In this case, there is nothing. So we have only 2 attributes, right? Ingredient ID and supplier code for ingredient supply. Okay. Right. So completed that part. Then so let's go to the next one. So there's another recipe, the same information, recipe names, recipe number, authors. In this case, there's only one author, then the different ingredients with different quantities, and the instructions for that particular recipe, and then the download information about the customers we already captured. Again, the ingredients supplied by many suppliers, right? And then this last table, what is this? So this is the supplier numbers and the name of the suppliers will be captured. Yes, we captured it. And then there are web addresses. All right, so we haven't captured that supplier information. So each supplier looks like having the web address. Yeah. So that is the possible attributes. Attribute in the supplier web address. Right. So web address. So we captured that. Right. So what they ask us to build an ERD diagram to solve this problem. If you don't know where to start, the next page. Yeah. Right. So I believe that looks like this is the final version for that particular problem. So how many strong entities? So 1, 2, 3, 4, 5 strong entities with 4 weak entities, right? And then we put all the cardinality constraints and cardinality relationships, I guess. And we have underlined other related relationships in order to indicate that we are grabbing that primary keys of respective entities, and we already recorded all the attributes, isn't it? Yeah. Right. So looks like this is the final version of that problem. Okay.